Hello, my name is Ricardo Garcia. I work at Igalia as part of its graphics team, and today I will be talking about the extended dynamic state Vulkan extension. At Igalia, I was involved in creating CTS tests for this extension and also in reviewing the spec when writing those tests in a very minor capacity. This extension is pretty simple and very useful, and the talk is divided in two parts. First, I will talk about the extension itself, and then I'll reflect on a few bits about how this extension was created that I consider quite interesting. So first, what does this extension do? Its documentation says that the extension adds some more dynamic state to support applications that need to reduce the number of pipeline state objects they compile and bind. In other words, as you will see, it makes Vulkan pipeline objects more flexible and easier to use from the application point of view. So, to give you some context, this is a typical graphics pipeline representation in many APIs like OpenGL, DirectX, or Vulkan. You've probably seen variations of this a million times. The pipeline is divided in stages. Some of them are fixed function, some of them programmable with shaders. Each stage usually takes some data from the previous stage and produces data to be consumed by the next one, apart from using other external resources like buffers or textures or whatever. So what's the Vulkan approach to represent this process? So Vulkan wants you to specify almost every single aspect of the previous pipeline in advance by creating a graphics pipeline object that contains information about how every stage should work. And once created, most of these pipeline parameters or configuration cannot be changed. As you can see here, this includes shader programs, how vertices are read and processed, depth and stencil tests, you name it. Pipeline objects are heavy objects in Vulkan, and they are hard to create. So why does Vulkan want you to do that? The answer has always been this keyword, optimization. Giving all the information in advance gives more chances for every current or even future implementations to optimize how the pipeline works. It's the safe choice. And despite this, you can see there's a pipeline creation parameter with information about dynamic state. These are things that can be changed when using the pipeline without having to create a separate and almost identical pipeline object. So what the extension does should be pretty obvious now. It adds a bunch of additional elements that can be changed on the fly without creating additional pipelines. This includes things like primitive topology, front face vertex order, vertex stride, cal mode, and more aspects of the depth and stencil tests, etc. A lot of things. Using them, if you need it, means fewer pipeline objects, fewer pipeline cache accesses, and simpler programs in general. As I said before, it makes Vulkan pipeline objects more flexible and easier to use from the application point of view, because more pipeline aspects can be changed on the fly when using these pipeline objects instead of having to create separate objects for each combination of parameters you may want to modify at runtime. This may make the application logic simpler, and it can also help when Vulkan is used as the backend, for example, to implement higher level APIs that are not so rigid regarding pipelines. I know this extension is useful for some emulators and other API translating projects. Together with those, it also introduces a new set of functions to change those parameters on the fly when recording commands that will use the pipeline state object. So knowing that, going back to the graphics pipeline, the obvious question is, does this impact performance? Aren't we reducing the number of optimization opportunities the implementation has if we use these additional dynamic states? Well, in theory, yes. In practice, it depends on the implementation. Many GPUs and Vulkan drivers out there today have some pipeline aspects that are considered dynamic in the sense that they are easily changed on the fly without a perceptible impact in performance, while others are truly important for optimization. For example, take shaders. In Vulkan, they are provided as SPIRV programs that need to be translated to GPU machine code, and creating pipelines when the application starts makes it easy to compile shaders beforehand to avoid stuttering and frame timing issues later, for example. And not only that, as you create pipelines, you're telling the implementation which shaders are used together. Say you have a vertex shader that outputs 4 parameters, and it's used in a pipeline with a fragment shader that only uses the first 2. So when creating the pipeline, the implementation can decide to discard instructions that are only related to producing the 2 extra unused parameters in the vertex shader. But other things like, for example, changing the front face, well, that may be trivial without affecting performance. Now, moving on to the second part, I wanted to talk about how this extension was created. It all started basically with an angry tweet by Eric Langell, sorry if I'm not pronouncing it correctly, who also happens to be the author of this previous diagram. He complained in Twitter that you couldn't change the front face dynamically, which happens to be super useful for rendering reflections. And he pointed out to an OpenGL NVIDIA extension that allowed you to do exactly that. And this was noticed by Piers Daniel from NVIDIA, who created a proposal in Khronos. That proposal was discussed with other vendors, software and hardware, that chimed in on aspects that could be or should be made dynamic if possible, which resulted in the multi-vendor extension we have today. In fact, RadV was one of the first Vulkan implementations to support the extension, thanks to the effort by Samuel Pitwase. And this whole process got me thinking, Khronos may sometimes be seen from the outside as this closed silo composed mainly of hardware vendors. And certainly there are a lot of hardware vendors, but if you take the list of promoter members, you can see some fairly well-known software vendors as well. And API usability and adoption is important for both groups. There are many people in Khronos trying to make Vulkan easier to use, even if we are all aware that that's somewhat in conflict with providing a lower level API that should let you write performant applications. If you take a look at the long list of contributor members, that's only shown partially here because it's very long, you'll notice a lot of actors from different backgrounds as well. And moreover, while Khronos and its different Vulkan working groups are far from an open source project or community, I believe they're certainly more open to contributions than what many people think. For example, the Vulkan spec is published in a GitHub repo with instructions to build it, because the spec is written in ASCII-Doc. And this repo is open for issues and pull requests. So obviously, if you want to change major parts of Vulkan and how some aspects of the API work, you're going to meet opposition, and maybe you should be joining Khronos to discuss things internally with everyone involved in there. However, while an angry tweet was enough for this particular extension, if you're not well known, you may want to create an issue instead, exposing your use case and maybe with other colleagues chiming in on details or supporting your proposal. I know for a fact that issues created in this public repo are discussed in periodic Khronos meetings. It may take some weeks if people are busy and there's a lot of things on the table, but they are going to end up being discussed, which is a very good thing. I was happy to see, and I want to put emphasis on that. I would like Khronos to continue doing that, and I would like more people to take advantage of the public repos from Khronos. I know the people involved in the Vulkan spec want to make the text as clear as possible. So maybe you think some paragraph is confusing, or there's a missing link to another section that provides more context, or something absurd is allowed by the spec and should be forbidden. You can try a recent pull request for any of those. So obviously no guarantees it will go in, but interesting in any case. For example, in the Twitter thread I showed before, I tweeted a reply when the extension was published, and among a few retweets, likes, and quoted replies, I found this very interesting tweet I'm showing you here, asking for the whole blend state to be made dynamic, and indicating that would be game-changing for some developers and very interesting for web browsers. We all want our web browsers to leverage the power of the GPU as much as possible, right? So why not? And I thought creating an issue in the public repo for this case could be interesting. And in fact, it turns out someone has already created an issue about it, as you can see here. And in this case, in this issue, Tom Olson from ARM replied that the working group had been discussing it, and it turns out in this particular case, existing hardware doesn't make it easy to make the blend state fully dynamic without possibly recompiling shaders under the hood and introducing unwanted complexity in the implementations. So it was rejected for now. But even if in this case the reply is negative, as you can see what I was mentioning, the issue reached the working group, it was considered, discussed, and the issue creator got a reply and feedback. And that's what I wanted to show you. And that's all. Thanks for listening. Any questions maybe? Okay. Hello, everyone.
Okay, so far we do not have any questions. Jason Ekstrom has a comment. We, the Vulkan working group, has had many external contributions to the spec.
Yeah, exactly. I mean, don't think it's very, very well known, but yeah, indeed, there are a lot of people who have contributed already issues and pull requests, and there have been many external contributions already. So these things should definitely continue and even happen more often.
Okay, I'm gonna ask a question.
Yeah.
So, how much do you think this is gonna help layering libraries like Zinc? Because I assume that, I mean, one of the big issue with Zinc is that you need to have a lot of pipelines precompiled. And is this helping Zinc? Or
I don't know if it's being used. I think I did a search yesterday to see if Zinc was using the extension, and I don't remember if I found anything specific. So maybe Zinc people can answer the question. But yeah, it should definitely help in those cases, because OpenGL is not as strict as Vulkan regarding pipelines. Obviously, you can change more things on the fly, and if the underlying Vulkan implementation supports the extended dynamic state, it should make it easier to emulate OpenGL on top of Vulkan. Mm-hmm. For example, I know it's being used by VK D3D right now to emulate Vertex 12. And there's a few emulators out there which are using the extension, because APIs for consoles are different, and they can use this type of extensions to make code better.
Agreed. Yeah. Jason also has another comment saying that there are even extensions in flight from the Mesa community for some windowing system related stuff.
Yeah, I was happy to see yesterday, or I think it was yesterday, well, here at this XDC, that the present time extension pull request is being handled right now on GitHub, which is, I think it's a very good thing. And it's a trend I would like to continue with because, well, I get sometimes, the discussions inside the working group and inside Chronos, well, they may involve IP or whatever. So it's better to have those discussions sometimes in private. But it is a good thing that maybe, there are a few extensions that could be handled publicly in GitHub instead of the internal tools at Chronos. So yeah, that's a good thing, and that's a trend I would like to see continue. Extension discussed in public, definitely. Yeah.
Yeah, sounds very cool. Okay, I think we do not have any other questions or comments. Okay. So that's it. Thank you very much. And
thank you very much. Let me congratulate you to the organizers for organizing XDC, and everyone enjoy the rest of the day. Thank you.
Thank you. See you in 13 minutes and